So for question number 1 on the 2014 AP Calculus AB for response, we're given a question about grass clippings and asked A through D questions about it. In my opinion, this is the hardest question of the 6, definitely the hardest, so let's get right into it. Grass clippings are placed in a bin where they decompose. For 0 to 30, the amount of grass clippings remaining in the bin is modeled by A of t is equal to 6.687 times 0.931 to the power of t, where A of t is measured in pounds and t is measured in days. Part A. Find the average rate of change of A of t over the interval 0 to 30. Indicate units of measure. Now, this question, rate of change means derivative. However, average rate of change, that just means, basically, in other words, how much do you start with, how much do you end with, divide by how much there were, and you get your answer. So it's almost like, well, it's basically slope formula. So the answer to A is actually just A of 30 minus A of 0 all over 30 minus 0. So the work for A looks like this. A of 30 minus A of 0 all over 30 minus 0. And that would equal to, well, let's get our calculator. Getting our calculator, it's A of 30 minus A of 0 all over 30 minus 0. So let's plug in 30. We get 0.931 to the power of 30 times 6.687. That's equal to 0.7829 blah 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 blah. So I'm going to right now subtract that from A of 0. Now anything to the power of 0 is 1, so it's really just subtracting 6.687. So 6.687. That's equal to negative 5.904 something something divided by 30, and we get our answer of negative 0.1968. So negative 0.1968. And our units of measure would just be pounds per days, because it tells us t is measured in pounds and t is measured in days. A of t is measured in pounds and t is measured in days. So that's the answer to part A. A little tricky. You just really have to understand what they're asking. It wasn't a derivative question. It wasn't even a calculus question. It was really more of a slope formula question. So part B. Part B is hopefully the one that everyone got correct. Find the value of A prime of 15. Using correct units, interpret the meaning of the value in the context of the problem. So this one's a straight out calculator problem. You go to math and derive of that whole thing, which is 6.687 parentheses 0.931 to the power of x, close parentheses, comma x, comma 15. And we get an answer of negative 0.1636. So B, A prime of 15, is equal to negative 0.16, it's a small 6, let me undo that, 636. Using correct units, interpret the meaning of the value in the context of the problem. Okay, so using correct units, if I draw a box, text box, this basically means that on the 15th, what is this? T is in days. On the 15th day, the grass clippings are decomposing at this rate of pounds per days. I guess you could avoid saying pounds per days if right over here you put pounds per days. But yeah, this is the answer to part B. Now part C. This is where it starts getting a bit tricky. I'm going to go ahead and scroll down and start C over here, even though it's quite tedious. Part C. Find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval 0 to 30. So right off the bat it says average amount of grass. Average amount. Average amount, I think of average value, which is integral, which is the integral divided by 1 over b minus a. So in this case, to start off this problem, not the answer, we would have 1 all over 30, because b minus a is 30 minus 0, and it's 1 over. This is basically how you do average value problems. 1 over 30 times the integral from 0 to 30 of a of t. So, dt. So, doing this on a calculator, math, function integral of 6.687, parentheses, 0.931 to the, close parentheses, to the power of x, close parentheses, comma x, comma 0, comma 30. That's 82.5791. Don't forget to divide by 30. And we get 2.7526. So now, because this isn't our answer, we're actually going to reuse this whole decimal thing. So right here I would write it's equal to 2.752635108. Now, we have a of t. Remember, the question asked us find the time t. So we found the average value. Now we want to find at what time t does it equal. So what we do is we're going to set a of t equal to this, because a of t is the function that they gave us for the amount of grass clippings, and 2.752635108 is the average amount of grass clippings in the bin. So if we set a of t equal to this and solve for t, we actually get the time t that tells us, or the time t that gave us this amount. So if we do a of t is equal to I'm not going to rewrite all that. Yeah, well, 2.752635108. If we subtract from this and set it equal to 0 and solve, we would have a of t minus 2.752635108. This is so tedious. Oops. 5, 0. That doesn't look like a 0. That's a 0. Set it equal to 0 and solve for t. So we need y. We have a of t, which is 6.687 times parentheses 0.931 power of x, close, minus 2.7, whoops, that's not a point, 0.752635108. Did I get that right? 7526351008, yes. Graph. Goes a little bit past. So if I go to my window and make x max, I believe, 13. I believe the answer is 12 point something. Graph. Interesting. Let's increase the graph a little bit more. There we go. So I will go to second calc, 0. Pick that as the left bound, and the right bound, I guess I'll put 15. Enter, enter. Oh, what's 12? The 0 is 12.4148. So that's actually our answer for part C. T is equal to 12.4, whoops, 4148. And that's the answer to part C. Now for part D, which is definitely the hardest question. Well, not so hard, but let's read it. For t is greater than 30, L of t, the linear approximation to A at t equals 30, is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time at which there will be 0.5 pound of grass clippings remaining in the bin. Show the work that leads to your answer. Alright, so it says the linear approximation. Linear means line, so I'm going to start with the point slope formula because that's my favorite equation of a line to use, which is y minus y1 is equal to m times x minus x1. Alright, so we need these values. We need x1, y1, and m. Luckily, not luckily, but we are given x1. x1 is actually a of 30. And a of 30, we're not given it, but you can tell it's a of 30 because the question says for t is greater than 30, L of t, the linear approximation to A at t equals 30. So we have the line here. We need the slope, which is going to be the derivative of, so it's going to be a prime of 30, while the actual x and y values, x1 is 30, while y1 is a of 30. So this is basically just finding the line tangent to the equation. So our equation is a of t, and we just want to find the line tangent to it. So x1, however, in this case, is 30, because it tells us right here for t is greater than 30. Or I'm sorry, right here, at t equals 30. So x1 is 30. y1 is equal to a of 30, which is the number we found earlier but did not write down. So let's write down a of 30. Turn this on. Since we did graph it, oh no we didn't actually. I can delete this. Delete. Let's go to table. Actually not table, table set. Start at 30 and do it this way. The y value is not there. Why is it not there? Okay, let's not do the table. Turn back on the calculator. Let's do this the old-fashioned way. 0.931 to the power of 30. 30. Oh, this thing loves glitching on me. 0.931 to the power of 30 times 6.687 is equal to 0.78299 278 694 1 2 3 4 5 6 7 1 2 3 4 5 6 7 8 9 10. Okay, so now we need a prime of 30. So m is equal to a prime of 30, because remember that's our x value. And a prime of 30 is, well, clear, math and derivative of 6.687 parentheses 0.931 close to the power of x close comma x comma 30. The value is negative 0.055976212 That's such a hassle. Alright, so now that we have all the values we need, let's solve for y. And I do not want to rewrite all this, so instead I'm going to rewrite this as y minus a of 30 is equal to a prime of 30 times x minus 30. Distributing and adding, we get y is equal to a prime 30 x minus 30 a prime of 30 plus a of 30. Alright, now let's plug this into our calculator. Have this. Let's go ahead and graph this. We have a prime of 30. A prime of 30 is negative 0.055976212 x minus 30 times a prime of 30, which is the same thing, 30 times negative 0.055976212 plus a of 30, which is 0.782927694. Now, that is our graph. However, before I continue, let's read this. It says, to predict the time at which there will be 0.5 pound of grass clippings remaining in the bin. So this, setting it equal to 0.5, meaning we subtract 0.5. So if we subtract 0.5, set it equal to 0, and graph, we should get our answer. And the answer is a large x value, past 30 I believe. So I'm going to put x max 40. And if I go to our and then if I go to second calc, 0, left bound there, right bound 40, find our 0. Our 0 is t is equal to 35.0544. And that is our answer to part D. Remember, I subtracted 0.5. So if I do a prime of 30 x minus 30 a prime of 30 plus a of 30 minus 0.5, set it equal to 0, solve for t, we get our answer. And again, this is because, well, to re-talk about part D, it says we have a linear approximation to a. So first let's find our linear approximation to a. So that's the derivative of this for the slope. And the point tells us right here at t equals 30. So x1 is 30, y1 is whatever a of t evaluated at 30 is, which is this number right here. And m would be a prime of 30, which is this number right here. I solved for y right here without rewriting the numbers, and then that's actually our linear approximation. But now it's asking us use that linear approximation to predict the time at which there will be 0.5 pound of grass clippings remaining. Remember, the answer to this, the y value, gives you the amount of grass clippings remaining. So we want to set it equal to 0.5 and solve for t. And that's just by, again, subtracting 0.5, setting it equal to 0, and graphing. And we get our answer of 35.0544. So this definitely was the hardest question out of the 6, in my opinion. If not, it'd be question number 4 with the related rates. However, I thought that was doable. This one was very tricky. Already with part A, it's not a calculus question. With part C, you gotta think of average value, and then kind of do the same thing with part D. Set it equal to the average value you found. Solve for t. In here, we had to use the linear approximation and use the that approximation, set it equal to the answer of 0.5, and solve for t. So it wasn't really that hard. The work is manageable. The actual process, though, getting to it, is a little bit tricky. It all comes down to whether you understand what you're being asked to do. If you understand what you're being asked to do, then these problems are, well, no problem. And definitely, if you had your hand calculator in, it'd be a lot easier. But I hope you guys enjoyed, and hopefully learned something from this problem. If you guys didn't get it right, or you think you did it right, then congrats. And I hope everyone did well on their AP test this year. So thank you for watching.